The next command that we're going to learn is the add command. And again, it will be a literal command and adding the values in the working register. The add LW instruction has the following format. And I didn't mention it before, but the instruction is the add LW and K. Everything after the semicolon is just a comment. So add LWK, add a literal value K to the working register. The add instruction tells the CPU to add the literal value K to register working reg, okay, R reg, W reg rather, and put the rest back into the working register. So it's keeping it right there in that working accumulator register. It's not moving it anywhere else. So once you add, then it just stays right there. So it's accumulating in value. Notice that in the add LW, first comes the letter, again, L for literal, and then comes the letter W for the working register, which means add a literal value to the working register, the destination. Add two numbers, and we'll see that. Let's see if I got here. Add two numbers. We're going to add two numbers, 25 hex and 34 hex together. So the first thing we have to do is we have to load the value into the working register. So move the literal value into the working register of 25 hex. Okay, so we've loaded that. Now we're going to give it the instruction to add 34 hex to that. So we're going to take the 25 that's already there, we're going to add 34 to it, and when we're done, we end up with a 59 in hex. You can see here how the literal value in the working register are fed into the arithmetic logic unit. We've got values that are fed from the register into the arithmetic logic unit, and then we've got on the right side, our carry bit and our status register. The 8-bit literal from the instruction word goes into the into the ALU, and then is cycled back into the working register. So let's take a look at another quick example. We're going to add four values together and end up accumulating them in the working register. So we're going to first move 12 hex into the working register, and then we're going to add a literal 16 hex or 1/6 to that 12. So at this point, 12 plus 16 gives us a value of 28 hex sitting in the accumulator. Now we're going to add 11 hex to that value. So 11 plus 28 gives us a accumulated value of 39 in hex. And then finally, we're going to add 43 to the 39. And so 3 plus 9 gives us C, and then 3 plus 4 gives us a 7. So you can see that in doing this, what we've done is in each case we've added a value to the original value that was moved into the working register, and it just keeps accumulating and accumulating as it cycles through each time. We'll go back to this as it cycles through each time through the arithmetic logic unit, and then it puts the value back in the working register. So that is the add command. When programming the working register, there are some things that you need to follow. First off, values can be loaded directly into the working register. There's no need for a pound sign or any other signs that are required for other microcontrollers. 2, if values 0 through F are moved into the 8-bit register as a working reg, then the result of the rest of the bits are assumed to be 0. And you can see here, for example, if we moved a literal 5H, we assume that to be a 05 hex in the register, and in binary notation you can see that the most significant bit 0000 is actually there as a binary number. Okay, it recognizes that. And then finally, if you move values that are larger than 255 or FF in hex into the register, it's going to give you an error. And there's a file out there. It's kind of like a log file. It's called a .error file. And it will tell you that in each case, you have exceeded the number of bits that you're trying to put in. So it chops off the most significant bit. So in the first one, move LW 7F2, it'll tell you it's illegal greater than 8 bits, and it chopped off the most significant bit, so it left F2. The next one, move LW 456 hex, again illegal, too large, greater than FF in hex, becomes 56. It chopped off the 4. And then finally, move LW 60A5. You can see that it chopped off the first two, 6 and 0. Even though there was a 0 there, it looked forward to the 6 and found out that the value was larger than it could accept. So those are 3 things to remember when you're moving values or adding values into the working register. It cannot be larger than 255 or FF in hex.